Dear students, welcome to this session on quantum mechanical model of atom. In this session, let us discuss about Hund's rule of maximum multiplicity. Now, this rule is applicable for filling up of electrons in orbitals. We have learned already some other rules regarding the same topic, that is Aufbau principle we have learned, Pauli's exclusion principle we have learned, N plus L rule we have learned. In continuation with that, now we have Hund's rule. Now, what does this Hund's rule state? The statement says like this. See, in the case of degenerate orbital, degenerate by which we mean orbitals with the same energy. So, in the case of degenerate orbital, electron pairing in any orbital will not take place until all the available orbitals are singly filled. So, let us explain that before. See, in the case of orbitals, we have to follow Aufbau principle for filling up of the electrons. So when we have say a single orbital, say in the case of s orbital, we have only one orbital concerned. So in this case, we have no problem in applying the Aufbau principle. But when you have a set of orbitals with the same energy, which is what we call it as degenerate orbital. For example, in the case of p orbitals, we know we have px, py and pz. So there are three orbitals with the same energy. Likewise, in the case of d orbital, we have say dxy, dyz, dxzx, dx square y square and dz square. So these are the five d orbitals. All these five orbitals have same energy, which is what we call it as degenerate. So in the case of degenerate orbital, we have to come into consideration this Hund's rule. Otherwise, Aufbau principle directly we can apply. Aufbau principle says that orbitals with lower energy are filled first, or we can say orbitals are filled according to their increasing energies. Now let us take one simple example. Say carbon, let us take. So in the case of carbon, the atomic number is 6. Now let us follow the Aufbau principle for writing the electronic configuration. According to Aufbau principle, 1s2, 2s2, 2p2 will be the electronic configuration. This numbers, the power represents the number of electrons, which means that in 1s orbital we have 2 electron, in 2s orbital we have 2 electron, in 2p orbital we have 2 electron. That if you we can draw the boxes like this. You see. So this is 1s orbital, this is 2s orbital, this one is 2px, this is 2py, 2pz. So these are the three orbitals. I mentioned about a degenerate orbital. These are the three degenerate orbitals of p which have same energy. Now, regarding again orbitals concerned, we have a special video about the shapes of the orbital. Do watch that. See, 2 electrons are present in 1s orbital. Let me draw those 2 electrons here. 1, 2. Okay. Again, in the 2s we have 2 electrons. So in this case, where you have only one orbital, pairing is not a matter. But here you see there are 3 orbitals with the same energy. So here comes the Hund's rule. Now I can write the first electron here. Now where to write the second electron? Either I have to write it here or here. So if I say, just for your understanding, let me do it like this. So if I draw the second electron here, what happens? So this is here only the Hund's rule comes into picture, or why can't I write it here? So Hund's rule states that electron pairing in the degenerate orbital is not possible until all the orbitals are singly filled or singly occupied, we can say. So we have 3 orbitals here. So only when these 3 orbitals are singly filled, then pairing occurs according to Hund's rule. So I should write the second electron here. Do you follow what I said? So in this way we can explain. Now let me write for other one example. Say nitrogen 7. So for nitrogen, how to write? 1s2, 2s2, 2p3 will come. So in this case, you see 1, 2, 1, 2. This is again 1s, this is 2s. I can write the same thing here. 1, 2, again third electron I am writing here because you have all the available orbitals are here and all these available orbitals are now singly filled. Now comes oxygen. Atomic number for oxygen is 8. See 1s2, 2s2, 2p4. how to write the electronic configuration. Again, we have a separate video for that. If you need to know about those, you can watch it. So in that case, you will have a better understanding regarding how to write the electronic configuration. Now, let me see how to fill this one. See, 1s2, no problem, you can just write. 2s2, again you can fill it. Here there are 4 electrons. So, first electron, second electron, third electron. Now, according to HUND'S rule, all the available orbitals or all the orbitals in the degenerate orbitals are singly filled now. Now, pairing occurs. See, the 4th electron will come here, and in this way, pairing occurs according to HUND'S rule. So, let me repeat once again the statement. According to HUND'S rule, in the case of degenerate orbital, where the orbitals have having same energy, electron pairing is not possible until all the orbitals are singly filled. Thanks for watching.